Yes, we're live? I have no idea. Is this thing on? I have no idea. Is this thing on? Looks like it is. Is this thing on? Looks like it is. Is this thing... Alright. Well, this is cool. This is, I think, my first, non-test stream. I'm still trying to figure out how to keep background music going. Just, keep stuff engaged as I work on understanding how the internet works a little bit more. It's always fun to try and understand what works, what doesn't work, how all the tools work together, how cameras kind of point one way to another. But here we go. We've got a channel. How exciting. Well, I'm trying to work on Advent of Code, which, if you're unfamiliar with, is a annual coding challenge that starts on December 1st and works all the way up to the 25th. Previously done 4 of the challenges. I guess a lot of people will do them on the day that they land, as an exercise, as a challenge. I tend to do them at my leisure, usually in batch. I've done 4, and this is kind of the progress bar. We're on December 21st, so the 22nd will unlock in 8 hours. But let's get started. I've got the challenge here, and then in order to switch over to my coding environment, I have to play around with these, which window is available. I'm not really sure if that's something. There's an easier way to do this, but I'm just gonna try this way, just by using the broadcasting tool to hide one or the other. So let's get into it. If you're joining, if you're watching, shout out in the chat. We'll try and get those responses here engaged, and let's give it a shot. All right, so text of the challenge. This has been following some elves. So the expedition can depart as soon as the final supply has been unloaded. Supplies are stored in stacks marked crates. Anytime they highlight something, that's good, usage of variable name, something to kind of notice. And then, let's see, because the needed supplies buried, the crates need to be rearranged. So we have crates, they need to be rearranged. Ship has a giant cargo crane capable of moving crates. To ensure none of the crates, the crate operator will rearrange them in carefully planned steps. Well, after the crates are rearranged, the desired will be at the top of each stack. The elves don't want to interrupt the crane. They will forget to ask her which crate will end up where, and they want to be ready to unload them. They have a drawing of the starting stacks of crates and the rearrangement procedure, the input. For example, this little diagram here, which is a little interesting. So we have 3 stacks of crates. Stack 1 contains 2 crates. Z is on the bottom, N is on the top. Stack 2 contains 3 crates. Bottom to top there crates M, C, and D. Finally, stack 3 has a single crate of P. The rearrangement procedure is given. Okay, so here's the key to kind of what the algorithm should be. In each step of the procedure, the quantity of crates is moved from one stack to a different stack. In the first stack, the above arrangement, 1 crate is moved from stack 2 to stack 1. So from here, we'll move stack 2 to stack 1, resulting in this. Okay, fine. 3 crates are moved from stack 1 to stack 3. Crates are moved 1 at a time. The first crate, D, ends up below, so that's D and Z. Okay. then both crates are moved from stack 2 to stack 1 because they're moved at one time, right? So that basically reversed the order. Finally, one crate is moved from stack 1 to stack 2. The elves need to know which crate will end up on the top of each stack. This is an example. Top crates in stack C in stack 1, M and Z. Give the elves CMG. After the rearrangement, what crate ends up on the top of each stack? Okay, so let's read it again. There's stacks, marked crates. There's a crane. And the procedure. So we've got 3 stacks. Rearrangement. Okay, so here might be the clue. A quantity. Doesn't tell me what quantity. Alright. One of the things that so they described how it moved, but they didn't explain like what it is. And okay, here are the description of the steps. So it's basically saying move 2 from 2 to 8. So that would move 2 to the top of 8. So that means C would be there at the end of this step, and so on and so forth. Okay, so if we go back to the example, this is the full challenge, right? So this is the input. So we need to like split our game input into 2 halves, one which is the starting state, and one are the different moves. So what I like to do with these is I like to create these as kind of a sample input. So let's go switch over to the code editor and talk about how that might work. All right, so I create a directory, and then in each one I create a solve.py file and add a little link at the top to today's puzzle, just in case. And we can see the same in the previous day. We do our inputs, we have an example, I do things, and then just run through. Cool. So example, what is this? Input. So because this is a multi input and we want to just use one input, whoops, I'm going to copy the example as is, because in the final input, or the real input, the input is one just really long thing, which looks a lot like this. That's the real input, but we don't want to try and handle all of that yet. We want to try and solve for this example input. So we have we need to split state from rules or from moves, so that way we can end up with 2 blocks. And the way we know the block is different is there's a new line, an empty new line. So text, it's going to be a string. It's going to output, I guess, a list of string. Right, or let's make it a 2-tuple. To split the text into first empty new line, and then with any luck we should have our Copilot here. Did I forget to install it? Forgot to install it. because I'm working on Gitpod, I have to install the Copilot SSH extension every time I fire up an instance. So now that I've got my Copilot, we should be able to get a prediction. So that's wrong. Split the input text. So what did this just generate on me? So it generated this weird... That's really what we needed to do. So the code generated isn't exactly perfect, but if we were to assert the len of that, we should get that assertion. So if you run the code, it exits cleanly, so we're able to split the text removes, and if we were to, state moves, blah, and we wanted to print out the state, and print out the moves, we can do the same with that, and we can see we have successfully split them apart, which is fine. Cool. So now that we have them split, we need to, I guess, parse the state columns into, I guess, what did they call them? Stacks? Yeah, we call them stacks from state. So split the stack into split state into stacks. So it's trying to split it on lines. It doesn't realize that they are columns. So let's try and prompt it a little bit better. So this won't exactly, again, it's going to strip a line for a line in split lines. So it's going to take this and try and provide, I guess, columns. Let's see what we get here. So let's actually get our state and moves. That way we can do that. We don't need that assert, that's fine. Let's see what we have here. Split stack columns from state, and let's just print that out. Let's see what we get. Let's get rid of this noise. So that didn't work, right? Why? Because state? Let's try this. Let's try debugging it. Yeah, VS Code. So where are we? State is nothing. Why is state nothing? Split state for moves. Huh. Okay, I didn't actually split it correctly. So that previous one where I was showing the state, that was wrong. Right, so let's print state here, might as well. Go back to run. And yeah, sure enough, we get nothing. So my split here is incorrect. So we want to split it on a blank new line. There we go. So because this end is a new line and this is a new line, those are the two new lines that I want to break on. Cool. I got that. That's better. So now if we were to print columns from state, I'm now getting column D and C. So it's splitting based on this line, right? So how do I do that instead? It's kind of weird because the stacks are at the bottom of the column, so there's no header. We kind of have to define a weird parser. Let's try something else. Yep. So Copilot wants to parse it all out into, again, to split lines because it thinks that each line is useful, but it's not. Each line actually has a lot of white space. How do we go about this? So I want to tell it, I don't know, that they're into, I guess we want a dictionary of keyed by column. So I guess if I wanted to represent a column, it might be a dictionary where the column ID would be 1, and then the contents would be ordered top to bottom. So I would want N Z, right? So this almost got it. It's DCM. So those are parse stacks, right? So now we need to parse stacks from state. So this is a little bit more complex because we've fed it a little bit of information here. So it's creating a stacks per line. If it has anything on that line, the stack would then split that line. And then the stack, I don't know, this doesn't sound right, but let's take a look at it. Print, parse, stacks from state for state, and give that a run. Yeah, that's a little wrong. So for line and state, all right. So we do have to operate on line by line. Could we instead reverse all of the lines? So that way the first line is the stack line? So that way at least we get a number. Yeah, no, we can't do that. Let's see, state dot reverse. Can we do that? Okay. Can't reverse an object. Alright. Let's not do. Oh, well. Should have been something like that, right? Doesn't have a method call. Yeah, alright, fine. Let's not go after that. Well, this one's a little trickier because this whole the data structure is the hard part here, right? Because once we have the data structure, we can parse out the moves, right? So let's pause on the parse stacks, right? So those are expected results. Let's see if naming it that gives it. That's still not it, is it? It's not going to be it. Why? Because we're still operating on this whole, like, split the line if it. Okay. Each column in state is 3 characters long and a space between stacks. Each stack is a list of 1 character strings. Some may be empty. Around it. Yeah, that's not it. At the bottom of each stack is a number of the stack. Let's see what this one does. For line in the state, strip the line. If there's no line, then continue. Fine. For item in split, if we split that, if that has a thing, then item append. Item. But that will append these onto the same stack. Python split text into columns. This is where Googling for answers helps a lot. So this one, Stack Overflow, talks about using pandas. Might be a little heavyweight for this, but could be useful. Alright, maybe not the most interesting. Alright, coming back to this, how do I take this input and read line by line and say, alright. Okay, so the first thing we need to know is the total length of the first line. Because once we have that, we can go character by character, right? So for the line, all right. So, nope. All right. If there's no line, but if there is a line, there's a contents on the line. Well, that stripped it, so that we didn't want to do that because that will put this at the beginning of the line. So we actually want to preserve the white space because white space is significant here. So there are no empty lines, but we want to determine total count of stacks from line length. Right, so 8 characters per stack, 1 space per 2 text. Stack count. There we go. So if we were to print stack count right here, and just run that, we should get a nice, I don't really care about the return here, but we should get a stack count as well. Well, that's not good. Oh, we're still doing the strip line. I don't want a strip line. So now we're up to 2 stacks. So let's just print our line, shall we? Cool. So split lines has this keep ends true. So we get here. And that keeps the line ending. So what does split lines do for us? Well, it's a little too much. Return a list, breaking at line boundaries. So the first line is D. Oh, we stripped it already. So don't strip it. There we go. Well, what does state look like? Alright, we're going to start using the debugger because that's easier than running the whole thing again. So, what does state look like right here? State looks like a new line. Why did it stay out? Okay. It's because I added a new line here instead of preserving the original new line, which that's fine. So let's try it again. Okay, now state starts with no new line. Okay. So when you advance all the way down till here, our stack count is 3, which is much better because we have 3 stacks. So this logic of how many we have is good. Cool. So we know how many stacks we have. So we could create an empty stack, right? And then on the given line, right? So we have a line that will look a little bit like this. So we have basically, we want to find the first position. In order to figure out which stack it goes on, we know how many stacks there are. We know how to position them. So we can read the string and say, where's the first character? Say I guess for every character in the string? I don't know. We still want to split the string up. But because the structure here could have this blanks in the beginning, blanks at the end, we can't always rely on the fact that there's an entry in the first column. So we do need to read character by character and figure out, find the position of the first non-space character. And this is the start. In the line. So don't do that, just do the so don't strip it. Let's see what that gives us. Let's try this again. Take those breakpoints. So the position for this one is going to be 4. Why is that? Because we line strip 0. Okay. Now we can determine the stack number and the position. And then assign the entry to the correct stack. So we have the position, and then once we have the position, and then we also have the next character. That only solves for one item in the stack. This is harder than I thought, and talking it out isn't helping. Well. What can we do with this? Well, we're still trying to turn this bit into something useful. So, if we were to do this, we'd probably get the wrong result, but we're getting closer. Let's see. So we loop through a fair amount of time. Let me clear this and then try it again. And then don't try and do this at all. Just do try and parse it. So what we got at the output is a frozen computer. Great. So the first print was the line, right? So we know what that is. Stack count, we have 3 stacks. Cool. First one is in position 4. Great. So that means this position is meant to be in stack number 1 as opposed to stack 0. And then the next line, which is in C, still have the right amount of stacks. This probably needs to be fix me. Can this be done outside the loop? And only for first line? Because once the stack count is done, I don't need to recalculate it every single time. As we can see, I'm doing the stack count every single time. So let's just turn off the print for a second, so we know how many. And then run again, just for some cleaner output. Let's get some more space here. So we can also see the line. All right. So there's position, stack number 1, position, stack number 0, and ZMP, which is the last line, comes back as da-da-da, and then we also get the numbers. So first thing we don't care about. So we also need to remove the bottom. Let's see what happens. If I get some sort of error. Yeah, because there's no line. And then dot strip. So basically, we've replaced 1, 2, 3, which that's not right. But if line row lines from the stacks that do not contain that or that. Continue. There we go. Thanks, Copilot. So we're printing the line. Let's print it after we've actually determined that we like the line. Cool. So we dropped the 1, 2, 3 at the bottom. And now we're trying to figure out. Okay. First crate position. Okay, so now we have position of the first crate. And we want to crate, and crate is surrounded by square brackets. Nope. There we go. Can you figure it out? So it's not the split. Let's do a quick helper function. Create ID from we know where the crate position is. We'll split the line into a list of crates. But we also want to know where they were on the line. So I kind of want to split, but I don't want to split and preserve, do I? Tricky. How do I want to do this? So I have the first crate position. First position is 4, right, for D. And we know D is meant to be in stack 1. So we want to put creates on a line. So this will give us back D, and then crate equals we also want to create ID. It's not really a create ID. Create letter. Right? All right, so this isn't going to work, but we know that we want D to be on stack 1, so we're expecting that at the end. Yeah, great. And then, I don't know, let's print out our parse stacks. Okay, so stack 1 has D on it. Say that it's not. We could try hinting this instead of having this opaque stacks dictionary and say, you know, make a data class, right? So the stack itself has a number and crates, which is a list of strings. So now that we have that, what else would we do something like that? That doesn't work, does it? Because I don't get a dictionary, I get a list. I kind of want a set of stacks. All right, I'm gonna have to think about this one a little bit more, but this was fun. Thanks for hanging out. I don't think I've solved it in the time that I wanted, but I got the experience of playing around with some live coding, some Twitch streaming, just trying to figure stuff out, which is always fun. But thanks for hanging out and watching. If you want to come back or have some critiques, feel free to hit me up. I'm on GitHub at github.com/MikeTheMan. I'm on Twitch, on all the other platforms. So thanks for hanging out today.